TikTok, where confidence is high and physics occasionally takes a week vacation. Today we've got a double feature. A man who thinks the Earth's rotation should fling us into space, and another who's deeply suspicious of the moon showing up uninvited during the day. I must fix both, quickly and clearly. Let's explore this. Hello there, welcome back to Star Stuff. You can call me Star Stuff. Or Caitlin. Or That Cosmic Girl. Or SSFE Battlestar. Or Barista of Cool Beans. Or Kate. That's totally fine. Okay, here's the first video.
With a sphere of 4,000 miles radius being spun round once every 24 hours, a little bit of calculations will show that that person there is being spun round at about 1,000 miles an hour and it doesn't know it. I mean, this is obvious nonsense. You go on a merry-go-round and it goes, I doubt, more than 10 miles an hour and you get off all dizzy. You mean to tell me that people can be spun round at approximately 1,000 miles an hour and not know it? Why, if this is so, this whole room that we're in is supposedly being spun round as something of approximately that order of speed, and we don't know it?
He must be joking. I sit here hoping he's joking. But I will address this as if he's not. Okay, so the claim is if the Earth is spinning at 1,000 miles per hour, which is 1,600 kilometers per hour, why don't we feel it? Why aren't we flying off? And honestly, fair question if you haven't met inertia. Okay, so Earth is rotating at about 1,600 kilometers per hour at the equator. But the important part is we're moving with it. Analogy time. You must imagine you're on a plane, you're cruising at about 900 kilometers per hour. You pour a drink, you walk to the bathroom, no one is screaming, "We're moving!"
Okay, it's happening. Everybody stay calm.
What's the procedure, everyone? What's the procedure?
Stay calm.
Why? Because everyone inside the plane is sharing the same motion. That's called inertia. Objects in motion stay in motion unless acted on by an external force. So why don't we fly off the Earth? 2 reasons. Number 1, gravity. Earth's gravity is constantly pulling you towards the center. That force is way stronger than the outward centrifugal effect from rotation. Gravity wins. And number 2, we're not suddenly accelerating. You only feel motion when something changes. Acceleration, deceleration, turning, or stopping. Earth's rotation is steady, smooth, and constant, with no sudden jerks or roller coaster drops. So your body's like, cool, this is normal now. If Earth suddenly stopped rotating, that's when you'd go flying 1,600 kilometers per hour, and that is not ideal. So no, Earth spinning fast is not the problem. Not understanding motion, though. Don't forget to leave a comment about that one. Let's see the next video.
So the moon is right there, and the sun is right there. Sun is there, moon is there. But the moonlight comes from the sun. Why isn't the moon full and fully lit when it's literally right next to the sun? I'm not understanding. How does that work? Are the flat earthers right?
I understand that not many people look up, ask questions, or do their own research on such things. But why would you so confidently show the world your tragic ignorance? The daytime moon is troublesome for many. It's the celestial equivalent to, why are you here? You don't even go here. So the question is, if the moon is supposed to be out at night, then why can we see it during the day? And the short answer is because the moon doesn't care about your sleep schedule. The moon orbits the Earth roughly every 27.3 days. As it moves around us, its position relative to the sun changes. That's what causes the phases of the moon. Now, this is a very important point. The moon is visible whenever it's above the horizon and when it's bright enough to see. That includes night, day, and those awkward in-between times where you're not sure what's happening in your life. Why can we see it in the daylight? Because it's still reflecting sunlight. Sometimes it's positioned in the sky when the sun is up, and the moon is at an angle where enough light hits it, and the sky isn't bright enough to completely wash it out. So the phases of the moon are to do with its position, not the shadow of the Earth. Okay, let's clear this up before it causes emotional damage, because I cut out parts of that video where that guy started throwing out F-bombs of frustration.
Are the flat earthers right? Are the f***ing flat earthers right, for f***'s sake, man? Like, what the f***?
The moon's phases are not caused by Earth's shadow. That only happens during a lunar eclipse. Now just go back and play that line again. Phases happen because we see different portions of the moon's sunlit side. Okay, so the sun on one side, the Earth in the middle, and the moon orbiting the Earth. As the moon moves, sometimes you see a full lit face, which is full moon. Sometimes half, which is called quarter moon. And sometimes just a sliver, which is crescent moon. And guess what? Many of those happen during the day. For example, the first quarter moon is visible in the afternoon and evening. Third quarter moon is visible late night into the early morning. And the crescent moon is often visible shortly after sunrise or before sunset. So the daytime moon is totally normal, completely expected, and not suspicious. For goodness sake. The real mystery is how this became controversial in the first place. So today we learned that Earth rotates at 1,000 miles per hour at the equator, and that's fine. You don't feel it because physics exists. And the moon shows up during the day. Also fine. The universe is not malfunctioning. If something in the sky looks weird, the answer is almost always, there's a perfectly good explanation for this. Not everything we know is a lie. Okay? Thank you so much for watching. If you enjoyed this episode of TikTok versus basic astronomy, don't forget to like and subscribe and drop a comment below. And remember, the universe is under no obligation to make sense at first glance, but it does make sense when you actually look into it. Cool beans.